Hey, it's Mr. Allred, and we're going to talk about rates, unit rates, and proportional equations in this video. So the first thing we want to talk about is rates. And a rate is a comparison of two quantities with units. So we'll try and keep the units with them so we'll know that there's a meaning that goes along with the numbers. Usually the comparison can be written as a fraction. A little bit later on we might change that. It can still be considered a fraction, but it may not be necessarily easily identifiable that way. So some examples here I might give you. We might travel, let's say, 600 miles in, let's say, I don't know, I need a reasonable number here, let's say 12 hours. So this is two quantities, 600 and 12, and there's two units here, miles and hours. They could be the same unit, but usually they'll be different types of units. Okay, but it's a comparison. 600 miles, and usually we think about that as like 600 miles in 12 hours. Another example might be, let's say, $50, and the unit there would be dollars, for, let's say, 30 gallons. So maybe we spend $50 on 30 gallons of gas, but both of those are quantities and have units associated with them. Okay, so taking that to a useful place, unit rates. So a unit, oops, my face is in the wrong place for that. Okay, maybe a little bit better. A unit rate is a rate with a denominator of 1. So this is usually accomplished by dividing out this fraction we just wrote. So an example could be this 600 miles in 12 hours. Now that's a rate, but if we actually divide that out, and I think I know what this is, but let's see, 600 divided by 12 is 50 miles per hour. So MPH stands for miles per hour. You could still write it as miles over hours, but we divide it. So it's 50 miles per 1 hour. So that's like a speed. The other one was $50 for 30 gallons. So if we divide that, let's see, 50 divided by 30 is, I'm going to have to round this off, and I'll round it off to the nearest cent, so I get $1.67 per gallon. So I could still write it as $1.67 over 1 gallon, but dividing it out makes it easier to compare. So these are unit rates because you only see one number, and it's assumed that the denominator would be 1. So as I just kind of hinted here, unit rates can be used to compare rates. So let's see here. I've got an example. Jesse finds 2 boxes of Tide detergent that is meant to be at a store. Box A is $4.50 for 20 ounces, and box B is $15.25 for 90 ounces. Which box is the better buy? So what we're looking at here is there's 2 different sizes, so they have different prices. But the question is, which one is more economical? So take out the fact that maybe you only have so much money to spend, and think about the idea of which one is the better buy or gives you the most per unit, as we're going to look here. So box A would be $4.50 over 20 ounces, and box B would be $15 $1.25 over 90 ounces. Now, because these numbers are nothing alike, they're the same units, it's really hard to compare. So that's where we'll go to the unit rate. So 450 divided by 20. This is basically 22.5 or 23 cents per ounce. So every ounce costs us about 23 cents when we buy box A. When we buy box B, we'll divide this, and I get basically 17 cents per ounce. So in this scenario, we pay less per ounce or less per unit with box B. So in that case, box B is the better buy. Okay, so if we know we're going to be buying detergent for the rest of our lives, considering that we're going to use it all no matter how much we buy, we'd like to pay as little as possible for each unit. So maybe box A costs less, but we're paying more per ounce there. Okay, so box B is the better buy, so we can use units to make comparisons. Okay, unit rates. So here we have the topic of proportional equations. Proportional equation. Proportional equation is an equation created by setting two rates equal to each other. Okay, so let me see what I've got here. I could do this as something that needs to be solved or something that doesn't, but I could say, let's say 600 miles over, what did we say up there, 12 hours. That could be a rate, it could be comparable to, maybe we're going to go, I'm trying to do something here, 840 miles. And the question would be, how many hours would it take us to do that? So if we have been traveling at a rate of 600 miles every 12 hours, which we've just decided was 50 miles per hour, we want to know how long it would take us to travel 840 miles. So there's many ways we could do this, but we've set two proportions equal to each other. And in that case, there's something we don't know and we want to solve for it. So if we have this, the general idea for solving a proportion is that you can cross multiply. So multiply one numerator times the other denominator. And if you do that, you kind of start to get a weird thing here. 600x on one side, and on the other side, my calculator, $10,080. So in this case, if we divide both sides by 600, treating it as an equation, I may have picked an odd thing here. Let's see here. I get 16.8, which, remember, x was in hours. So that means it'll take me 16.8 hours to do this. There's other ways you can answer that question or figure that out, but that's an example of a proportional equation. Two proportions set equal to each other, and it's an equation because there's something we don't know that we're trying to find out. Alright, let's sneak down to this example. Paul completed a 20-question test in 35 minutes. Based on this, how many questions could he complete in a 50-minute class meeting? Round the answer to the nearest whole number. So one thing you got to be careful about is how you're going to round things. So we're going to set up our proportion, which means we need one rate, and that rate needs to come from two things that are being compared. So in this case, it doesn't really matter, but we could say 20 questions in 35 minutes. And that's going to be equal to, we don't know how many questions he can solve, in 50 minutes. But what we're going to do is we're going to cross multiply this proportional equation, and when we do that, on one side we will have 35x, and on the other side I think we will have 1,000. Even though I think it might be good for me to use the calculator. Yes, 1,000. I'll divide by 35 to get the x by itself and solving the equation. So I said round to the nearest whole number. I get about 28.57. So we're going to say that that is about 29 questions. So based off of how fast Paul works in class, it looks like I could try to ask him or give him a test that had 29 questions on it. Okay. Let's see. Here is the last example I'm going to have. You don't want to see. Jayla has a recipe that requires 40 M&Ms to make 25 cookies. If Jayla wants to make 300 cookies for a bake sale, how many M&Ms should she use? So let's set up our proportion. So let's see. 40 and 25 go together. So 40 M&Ms make 25 cookies. 40, and we'll just say M&Ms, make 25 cookies. So that's the two things we're comparing. And if we put units with them, it helps us kind of keep things straight. Especially if they're different units, they need to be lined up. So you want to take the scenario that's related, like the 40 M&Ms make the 25 cookies, and then the other proportion, it says if Jayla wants to make 300 cookies, so that puts 300 in line with the 25. How many M&Ms does she need? Well, we don't know, but it goes in line with the 40 M&Ms. So we'll cross multiply, and I'm going to say this is 12,000. We'll pick up a calculator. So 40 times 300, 12,000. And the other cross multiplication is 25. Let's go back to the right color. 25 times x is 25x. We'll divide by 25 to get x by itself. 12,000 divided by 25. It looks like she will need 480 M&Ms. Now those are silly little examples, but they give you the workings of how proportions and rates behave. You can't always count on things coming out to be nice whole numbers, but the main thing is to set your rates up correctly and be careful when you solve. Okay, rounding will be a big issue for some people, but we'll do the best we can.